Hi all. In this video, let us learn the corrosion control. There are three types of corrosion control we have in our as per our syllabus. The first one is inorganic coating. The second one is a cathodic protection, and the third one is a metal coating. Let's go to the first one. Let's learn the first one: inorganic coatings. It is also known as chemical conversion coatings. What do you mean by this inorganic coating or chemical conversion? Why it is called chemical? The reactions which occurs here inside the corrosion control method plays a main role here. That is why it's called chemical conversion coatings. These coatings are produced at the surface of the metal by chemical or electrochemical reactions. We have two examples for this: anodizing and the phosphating. But in our syllabus, we have only anodizing. We do not have this phosphating. Let us concentrate only on the anodizing. It is also known as, sometimes it is called anodizing of aluminium. Anodizing of aluminium is the process of oxidation of outer layer of the metal. Metal here particularly aluminium, because we already called this as a anodizing of aluminium. Therefore, that metal should be aluminium. So anodizing is a process of oxidation of outer layer of aluminium metal to its aluminium oxide, that is metal oxide, by doing electrolysis. Oxide layer formed over the metal surface itself acts as a protective layer, because here whatever the aluminium gets converted into aluminium oxide, that aluminium oxide behaves as a barrier, protective layer, which prevents further corrosion of that aluminium metal. That is why it is called anodizing of aluminium. For this, we need to take some of the anode material, cathode, some voltage we have to put there. So conditions for the electrolysis, what are those conditions? The first one is anode. Whatever the metal we are studying, it acts as, it is made as anode here. Aluminium is made as anode. We are dealing with aluminium metal here. So aluminium is made as anode. And a steel or a copper is made as a cathode. And 5 to 10% chromic acid behaves as, are made as electrolyte. Temperature is maintained at 30 to 40 degrees centigrade throughout the coatings or the reaction. And the applied voltage is 0 to 40, maybe 35, 32, up to 40 volts we can put. And how this occurs? This is the small procedure we have. Aluminium is made as anode and a copper or a steel is used as a cathode, and the electrodes are immersed in an electrolyte, that is 5 to 10% chromic acid. Inside this chromic acid solution, we have to immerse the aluminium, steel or copper as anode and a cathode respectively. And the temperature is maintained at 30 to 40 degrees centigrade. The potential of 0 to 40 volt is applied, which oxidizes the outer layer of the aluminium into aluminium oxide, Al2O3, and that get deposited over the metal, and the reactions involved are as follows. This is the anodic reaction, that is 2Al plus 3H2O gives Al2O3 plus 2 hydrogen ions plus 2 electrons. At the cathode, the 6 hydrogen ions plus 6 electrons gives 3H2, and overall reaction is 2Al plus 3H2O gives Al2O3 plus 3H2. That means here the main product of the reaction is aluminium oxide that gets deposited over the metal, aluminium metal, and it acts as protective layer. We can see this industrial image, how the inorganic coatings can be carried out by taking anodizing of aluminium as example. These are the some picture. Now coming to the second one, cathodic protection. What is the principle of this cathodic protection? How we are going to protect the metal from the corrosion using this cathodic protection? Let us go step by step here. The principle is to force the metal to be protected to behave as a cathode. This is the main principle here. Whatever the metal we want to protect from the corrosion, we have to force that metal to behave as a cathode. For example, if we want to protect the steel or the iron, we have to make that iron, we have to force that iron metal to behave as a cathode, so that we can avoid the anodic reaction, because only at the anodic region the corrosion occurs, we all know that. So we have to avoid that anodic reaction. That means we have to made it to behave as a cathode. There are two types of cathodic protections we have, namely the sacrificial anodic protection and the impressed current cathodic protection. Sacrificial anodic protection. In this type, the metal to be protected is connected to the more anodic metal using a metallic wire. The more active metal gets corroded while the parent structure is protected from the corrosion. The more active metal is so employed is called sacrificial anode. The sacrificial anodes to be replaced by fresh ones as and when it is required. Commonly used sacrificial anodes are the magnesium, zinc, aluminium. So what is this method? Sacrificial anode? One gets sacrificed itself to protect the other one. That is the meaning of sacrificial anodic protection. The metal to be protected is connected to the more anodic metal using a metallic wire. With the help of some metallic wire, we have to connect that metallic wire, metal to be protected to a more anodic metal like magnesium, like a zinc, or like a aluminium. We have to connect. For example, if you want to protect a steel, buried steel, then that steel is connected to this magnesium pipe or zinc or the aluminium, because magnesium, zinc, aluminium behaves as anodic metal, they gets corroded, whereas the buried pipeline or the steel pipe gets protected. The more active metal gets corroded while the parent structure is protected from the corrosion. Example, the well-known example we have here, steel pipe is protected by connecting it to a block of zinc. In this case, steel acts as a cathode and it is unaffected, protected from the corrosion, and zinc acts as a anode. That is what? Sacrificial anode, and it can undergo sacrificial corrosion. This is the rough diagram, diagrammatic representation of this sacrificial anodic protection. We have a zinc block here, which is connected to the steel pipe, which acts as a cathode. Zinc being anodic metal, it gets corroded while the steel pipe gets protected. This is the real image where the sacrificial anodic protection is implemented. This is a sacrificial anode, like a zinc block. This is a buried pipeline you can see here in this picture. If you connect this buried pipeline to this steel pipeline to the zinc gets corroded and it is protected. This is how we can actually implement this sacrificial anodic protection method. And also we can see this example in the boat hulls. These are the boat hulls. Outer frame of the boat is called hulls. All the boat hulls are connected to the more anodic metals such as zinc or aluminium or magnesium. These are some magnesium and zinc blocks, which is connected to the boat hull. Because it's always inside the water, there may be a chance of getting corrosion. So in order to control that corrosion, this sacrificial anodic protection employed in the boats. Second one, impressed current protection method. In this method, electrons are supplied from a source of direct current, and the metal structure to be protected acts as a cathode, and it is connected to the negative terminal of the battery. The inert metal like graphite acts as an anode, and it is connected to the positive terminal of the battery. When DC current is applied in a reverse direction to nullify the corrosion reaction, then anode is inert metal, no reaction takes place at anode, and therefore cathodic metal is protected from the corrosion. This is what graphite, inert anode. Since it is inert, no reaction occurs here. And therefore, this whatever the metal we have here, which is under control, that is protected. Again, this implementation, the diagrammatic representation of this here. Then we have the last method, metal coatings. Third method, metal coatings can be applied on the base metal by hot dipping process. I'll explain this hot dipping process. What is this in the next few minutes? This method is used for producing a coating of low melting metals such as zinc, aluminium, tin, etc. on iron or steel metals which have relatively high melting point. Example, galvanizing and the tinning. We have only one example here, galvanizing. We do not have this tinning in our syllabus. Let us concentrate on this galvanizing. Galvanizing or galvanization, both are same. This means coating of a zinc on iron or a steel by the process of hot dipping. It's called galvanizing. Here we have to observe this zinc melting point, low melting point. This is. That is why in the beginning here, coating of low melting point metals such as zinc, aluminum, tin, etc. on the iron or steel metals. So here, this is a low melting point metal zinc. This is coated on the iron or the steel by the process of hot dipping. It's carried out as follows. There are some steps here. The iron sheet is subjected to pre-treatment by degreasing with organic solvents such as acetone or alcohol. With any organic solvent, we have to remove the grease content. That is called a pre-treatment. Then it is followed by the sheet is passing through dilute sulfuric acid to remove any rust. Washed with the distilled water and then dried by supplying the hot air. Then the iron sheet is dipped in molten bath of zinc at 419 degrees centigrade and surface is covered with a ammonium chloride flux, which prevents the oxidation of a zinc metal. Otherwise, what happens? There may be a chance of undergoing oxidation of zinc into zinc oxide. To prevent that oxidation of zinc, ammonium chloride, which is covered, which is added, acts as a flux. The excess of coated metal is removed by passing through a pair of hot rollers and it is cooled gradually. You can see this flow chart. Iron sheet is immersed in a tank which contains an organic solvent. Then it is passed into a dilute sulfuric acid. Here, rust is removed out. Then it is washed with a distilled water and also it is dried then by passing the hot air. Then it is immersed in the fourth container which contains molten zinc. It is boiled at 419 or 420 to 430 degrees centigrade. Here, the reaction occurs. That is, the coating of this metal occurs over the metal, iron metal. This is what the industrial procedure, industrial images, where the molten zinc is molten. The iron sheet is immersed inside the molten zinc bath. This is the zinc bath. You can see this picture. This is about the galvanization.